Well, thank you. Good afternoon. I apologize for my coarse voice, which is due to some health problems I've had recently. My presentation will be we'll be dealing with yeast and fermentation and how to manage the fermentation stress. I will describe the Mycostart protocol, which has been underway for some time, and the benefits that we've seen, the results that we've obtained thanks to this protocol, and some cases of implementation. First of all, the Mycostart protocol provides a different approach, or at least partially different, from the standard yeast preparation for fermentation. It is true that you can add substances such as sterols, and the survival factor has been discussed in order to improve the overall yeast survival, but our approach also considered how to make the yeasts work differently to make them more efficient. So we'll be dealing with metabolic mechanisms and how to prepare yeasts for alcoholic fermentation, and how to grant the cell a healthy state to respond to fermentation stresses in the best possible way. As Agostino said, alcoholic fermentation is stressful for the yeast. Stress can be defined as a situation that can compromise the survival of a yeast. Alcoholic fermentation begins when the yeast cell, has acclimatized to the new environment. These are all the stress factors that Agostino Cavazza has listed already. Certainly the high osmotic pressure, that is the humidity and salt gradient between the cell and what's outside the cell. As Cavazza said, dry yeasts have a humidity of less than 7%, and they have to rehydrate it to more than 30%. Temperature variations are also a stress factor, and you have to keep in mind that during fermentation, progressively, the ethanol content will be increased, and hence the toxicity of the fluid. Also, in terms of the membrane fluidity of the bubble, the soap bubble that contains the yeast. And then you also have to keep in mind that there's a continuous limitation and reduction of nutrients. The Mycostart protocol aims at stimulating and maximizing yeast resilience. In other words, the yeast's ability to face up to hard situations and stay viable. What are the key points of the protocol? Essentially, there are three such key points based on the rehydration process, whereby it is essential to provide water to the yeast cell so that it will start its active life again, and also for it to regain its physiological suppleness. The product, a bioactivator using selected yeast hulls, there is particularly rich in vitamins, microelements, and growth factors and survival factors, and then reactivation, which is needed to reactivate cell respiration before fermentation is initiated. There's one effect that acts as a switch for yeast that switches the yeast onto fermentation or respiration. This effect is known as the Crabtree effect, and it works also at low sugar levels. The yeast will begin fermentation very early, even at low concentrations, but it could be positive for people working on alcoholic fermentation. That produces also CO2, which has an oxidative function for that is relevant for many products. Fermentation will obviously cause, in turn, a lower energy production in the form of ATP. Then you also have other effects on the mitochondria, the citric acid cycle, and the diminished production of sterols and fatty acids. With our Mycostart protocol, we intended to reduce the Crabtree effect exactly during yeast rehydration. Now here is the respiration mechanism. We know from studies that fermentation is not providing much energy, while respiration can provide energy in the form of 38 molecules of ATP. So the Mycostart protocol favors respiration, making it possible for cells to gain as much energy as possible before fermentation starts during reactivation. The effects of this process come in the form of energy variations. More ATP is produced, in other words, more energy. That ATP regulates the entire operation of the cell during fermentation. More ATP means more cell viability. Then there will also be an opportunity to have more reducing potential or power, which is very important because the last stage in production is the reduction of acetaldehyde to ethyl alcohol. And then you have phosphorylation of fatty acid precursors, namely glycerol, which are needed to synthesize fatty acids, and sterols, which are components of the cell's membrane. Obviously, if we can activate cell respiration, then we will produce long-chain fatty acids, as well as precursors, amino acid precursors that might also provide different fermentation aromas and flavors, as well as precursors for biosynthesis. Obviously, Mycostart is a complex project. Much attention was given to the selection of vitamins which are necessary, including pantothenic acid, riboflavin, and cations, and magnesium and zinc cations. There's an increase in the production of unsaturated fatty acids, and there's an increase in phospholipidic ratios with an acceleration of the synthesis of squalene and ergosterol. Trehalose production is also increased as a cellular adaptation thanks to the Mycostart protocol. And I would like also to stress a better protonic pump operation, which is very useful. We've gone through studies, and I'm heading towards my conclusions in cooperation with the Studio Michelet of Conegliano. There was a test where there was a traditional yeast rehydration with an acclimatization with a must with 50 grams per liter of sugar, and then a sample with a rehydration with water and acclimatization at a low sugar concentration, 10 grams per liter. And then we also implemented a rehydration protocol with water and low sugar concentration plus oxygen. You can't really see this, but volatile acidity is very different in the three samples. Fermentation pattern. The fermentation pattern shows that the red line, which is sample number 3 or test 3, is basically better than the other two because the metabolism is entirely focused on fermenting and therefore there is less yeast stress. If you look at the production of acetic acid or volatile acidity, production using oxygen is half the traditional protocol. We've run other vinification tests using Mycostart. This is Pinot Gris. Probably the substrate, the medium, was already polluted, so before the inoculation there was already a high level of volatile acidity around 0.6, while fermentation with the selected yeast reduced it to 0.1 only.
Sono così importanti. Questo è il protocollo.
This is the Mycostart protocol. There are several protocols for rehydration in function of the needs and also in function of the goal of the process itself. We have a first phase, which is rehydration of yeast, which is done with plenty of water at a temperature of 37 degrees centigrade. The yeast is left in this condition and then it is mixed again, stirred again for 20 minutes. Then there is a reactivation phase of the yeast itself where Mycostart is added, 1:5 ratio vis-à-vis the yeast. You add sugar, approximately 5 grams per liter. And you also administer oxygen at the maximum available dose with the oxygenator. The duration of the process is approximately 2 hours, while keeping this mass stirred, and you obtain 22 liters approximately. Then there is acclimatization of yeast, which is done for the Prix de Mousse. You add 1 hectoliter of base wine with sugars. This is done progressively and repeatedly until you reach 5% of the mass to be inoculated. Also, in this case, you keep a controlled temperature and you progressively take it to 20-22 degrees. Then the yeast is inoculated following the nutritional strategy that has been established. Of course, attention has to be paid to avoiding abrupt temperature changes. Thank you for the attention, and I apologize for my hoarse voice.